Hey friends, a colorful welcome on my channel to all of you, and today we are going to learn electrostatics from class 12. Okay, so what is electrostatics? From the name it suggests that electrons which are in static or charge at rest, right? So from example you can relate that things. We often observe a spark or hear a crackling sound when we take off our woolen clothes, right? Or more popular examples comes when a plastic comb run through the dryer, it attracts pieces of paper. So they are the example of electrostatics, or it also sometimes called frictional electricity. So why frictional electricity? Because when they are rubbed or get in contact with each other, they develop some charges, and most importantly the developed charges cannot move from one place to another. So that's why they are static as well as they are static electricity. So first in around 600 BC, Greek's philosopher Thales find out a object called amber. So from that amber, he saw some such phenomena, and later on, it's the meaning of amber is electron. Okay, so the meaning of amber is electron in Greeks, and the words related to electron owe their origin from electron. Okay, so and later on Benjamin Franklin introduced the concept of polarity of charges. As we all know, so charges are two types. In case of polarity, one is positive and another is negative, right? Charges. Some charges are positively polarized and some charges are negatively polarized. Okay. So when they're rubbed or due to frictional electricity, when two objects are rubbed, some mass also changes. How mass changes? We all know. In case of frictional electricity, the charge is transferred from one body to another body. So the charge actually the electron transferred. Okay, so the electron are single electrons of some finite masses. So when some number of electrons transfers to one body to another body, definitely some mass will change. Okay, the body which will gain electron will gain some mass, and the body which will lose electron will lose some mass. Okay, so uh, there are many types of process by which we can charge a body. There it is a it is one kind, frictional electricity or by friction. There are induction, conduction, as well as photoelectric emission, field emission, thermal emission, by which we can also charge a body. Okay, so next comes in the chapter quantization of charges. So what is quantization of charges? It states that, or it suggests that any existing charge in the nature must have some integral multiple of electronic charge E. When it is electronic charge, it is only E. The E value has 1.6 into 10 to the minus 19 Coulomb. So when it is electron, it is negatively charged, and when it is proton, it is positively charged. So both of them are simultaneously called electronic charge, and we can say that that electron is one of the most fundamental particle or elementary particle in nature. Okay, so there must not be any charge which will not follow this equation, where n belongs to positive integer, or we can say 0, 1, 2. Okay, so although in modern time we can say there are more elementary particle quark. As we know, quark it is right. Quark has also some different types, up quark and down quark, and many other types. I will discuss. Okay, I limited it to that point. And up quark has charge of positive 2/3 of electrons, and down quark has charge of negative 1/3 of electron. Although our limitation will be this q equal to any. That means any charge existing in nature cannot be are discrete multiple of electronic charge. That's mean any charge, suppose say 5 Coulomb charge, so that charge must be some n into electronic charge. That means this charge must contain some integral number of electronic charge. So by summing that integral number of electronic charge, we will get that 5 Coulomb charge. Okay, so that is the most fundamental. Now comes to, as we all know, the conservation of masses, conservation of energy. So in case of charge, there is also conservation of charge. Okay, so conservation of charge means, as we all know, in case of conservation of masses, the mass cannot be created or destroyed, right? So the total mass in the world or nature must be constant, as well as energy, in case of energy. Okay, so that's also true for charges. So charges cannot be destroyed or created. The total amount of charges in the world is same, or we can say in any system the total amount of charges must be conserved. So any reaction you can take from anywhere. So the most popular reaction, the nuclear reaction, we can say that is uranium bombarded with a neutron, slow neutron or thermal neutron, and it will comes to outbreak of barium plus krypton. Krypton has 92, yes, 92, and 3 neutron as well as some energy. Okay, so look at that equation, that nuclear equation. The mass number or the nucleons number are conserved. Here 232 plus 1 233, here 144, 92 and 3, total also 233. Okay, yes, and in case of 92, yes, okay, in case of electronic number or atomic number, the here it is 92 and here it is 56 plus 96, it is also 92. Okay, 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 yes, 92. Okay, so next we will going to Coulomb's law. So Coulomb's law. So what Coulomb's law states? It states that when 2 point charges, there is some condition for Coulomb's law. Okay, when you write the Coulomb's law, you have to mention those points. One, the 2 charges, when you are taking 2 charges, let's say Q1 and Q2. So for the application of Coulomb's law, or Coulomb's law is only applicable if the charges are point and static. So we can say point static charges. So he states that the forces between two static point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Okay, so if we take the amount of charges is q1 and q2 and we take the radius vector or distance between them is r, then we can say the force between them, as we all know, 2 charges, either they will attractive in nature or repulsive in nature upon their polarity. If they are same kind of charge, they will attract, they will repulsive in nature, and if they are opposite kind of charge, then they will be attractive in nature. Okay, so we have no idea whether they are that is directly proportional to, Okay, so the force between them will be directly proportional to the product of their charges and inversely proportional to the square of the distance between them. So we can write, so there will be appear a proportionality constant K. So in case of Coulomb's law, this proportionality constant in SI system is 1 by 4 pi epsilon naught. So what will epsilon naught, or what is epsilon naught, I will come to that later, but first that is the outcome of the law, the mathematical expression. But as we all know, force is a vector quantity, right? So that must have some direction as well. So we find out here the magnitude. So the direction will be, you have to take a reference point. If you say it is from Q1, so direction of the force will be along the distance or radius vector, we can say. Okay, so we can write it force equal to r cap. So why r cap? R cap means it is a unit vector along r. So to make it a vector quantity, we just multiply a unit vector. And now if the force is attractive in nature, then it will be negative sign, and if the force is repulsive in nature, then it will be positive sign. Okay, so as we all know the concept of that force, I don't know whether you know or not, but it is that if the negative charge suggests it is the attractive force, and positive charge positive force suggests that it is a repulsive force. Okay, so that is the vector statement or vector expression for Coulomb's law. And now we will move on to superposition theorem. Okay, before that, one important thing, in case of Coulomb's law, the Coulomb's law is similar to the Newton's law in gravitation, right? In class 11 we see that. So it is almost similar, but there are some differences, key differences. The most important difference between Coulomb's law and Newton's gravitation law is, here it can be negative or positive, that means attractive or repulsive in case of Coulomb's law, but in case of gravitation, the Newton's law, it always attractive. Okay, that is the key difference. And both forces are central forces. What is central forces? They act along their joining line. Okay, so central forces. And most of the law which follows the inverse square law or inverse distance law, so they are conservative in nature. So Coulomb's force is not exception to this. So Coulomb's force is also conservative in nature. Okay, so work done due to the Coulomb's force does not depends upon the path independent, or along a cyclic path the work done is 0, we can say. Now comes to superposition theorem. So Coulomb states that for two charges it is valid, we can find out the force easily. But what happens if multiple point charges, static point charges, acting simultaneously? Okay, suppose take it Q, and that Q1, Q2, Q3 Qn. Okay, so Qn. So the distance between Q and Q1 is R1 vector, R2 vector. Okay, Q3 R3 vector, Qn Rn vector. So how to find out the total force on Q? Okay, so the superposition theorem suggests to find out the total forces or resultant forces on Q, we can find out the forces separately realized by the charge Q by other charges. So if F1 force due to Q1, F2 force due to Q2, and Fn force due to Qn, and the most importantly, those forces will not affect each other. That suggests the superposition theorem. So you can say, you can see that if Q1 is here and Q is here, suppose they are repulsive force. So Q will try to repulse Q1 and Q1 will try to repulse Q. So that means that Q must change its position. So if this position changes, those R2, R3, Rn all values will be changed. So the force value will be changed. So the Coulomb's law will not be applicable because this charge does not remain steady. So to find out the resultant forces, we will consider this Q charge is steady and we will individually find out the forces and we will sum it according to the vector addition. So by this vector addition we can get the resultant forces acting on Q. So that is the superposition theorem. So here we will end our first chapter, Coulomb's law. On the later video we will discuss about the next chapter. Till then, goodbye. Okay.